Thanks, Mark. So, hi everyone, my name is Lassi Tani and I'm from Spatial World. That's a Finnish company. And I'm going to talk about automatic validation of XML-based water monitoring data. So, if you think about XML, there's a lot of XML all over the world, and it's not always easy to use. It can be very complicated, it can be even scary, and some might say, I hate XML. But I think I was in that phase also when I started with XML. But FME loves XML, as you should all know that FME loves XML. And if FME loves XML, then I should also love XML. This might sound very cheesy, but I'll show you why this is the truth. So I'm Lassi Tani, I'm an FME consultant and a trainer from Spatial World, which is a Finnish company, as I said, and I've used FME since 2005, and fortunately Workbench was already there at that time. And at the moment I do lots of XML, GML, IFC and all kinds of different web services. And as you can see, my hobbies are track and field and computer music. Just don't expect me to run 100 meters under 10 seconds because I just started 3 years ago track and field. So, and I'm really interested and excited about the new transformer which converts workspaces to beautiful music. So I'm doing computer music too, so I might try that transformer. And our location is here, quite far from Vancouver. Espoo is our city where our office is based at, and it's in the southern part of Finland, just next to Helsinki. And basically, the topic or the core of the project that I did for one customer is changing the manual work to automatic with FME. And this is not always in our minds when we are doing processes with FME, but this is actually the main biggest points why we use FME for transforming data. And we shouldn't forget that FME does this automatic. So the customer which I'm working with is Finavia. Finavia is responsible for maintaining all the Finnish airports, so 22 airports, and Finnish air navigation system. And there are over 20 million passengers annually which are using these 22 airports in Finland. And there are 2,400 employees in Finavia. They are investing heavily, over 900 million euros investments this year to the airports. And of course the Helsinki airport is the most important one. And when they are doing this, so a lot of investment to all the airports, and they are building new buildings, they of course need a lot of data, and they need to handle that data automatically. So the water monitoring data that this project is all about is can look like this. There's a lot of snow in Finland, not always, but there are different observation points all over the airports, and there's a man taking sample from the observation point, and basically they are measuring the ground and surface water. And there are over 350 observation points all over Finland, the Finnish airports. And different laboratories are producing this data, and of course that means that there are different data models that these different laboratories use, and different formats and data models, Excels, even PDF, docx, and they were sending these results, these analysis results by email to Finavia, and all the processing was done manually, and they basically manually imported the data to Finavia's database. So there was a lot of possibilities to automation, and they are monitoring over 160 different analyses, such as temperature, smell, pH, oxygen, and electrical conductivity, and etc. And here you can see on the right side there are the observation points of Helsinki airport. And here in the low part you can see the analyze results, where the observation points are the rows in the database and the columns are the analyze results. So the solution looks like this. The XML data is sent to Finavia with shapefile, and the data providers are forced to use this XML data. It's a Finnish water monitoring standard, XML standard. And secondly, FME server is checking if the shapefile folder has new data. And then data validation is done by FME, and the data is validated using a standard XML schema. Then, if the data needs fixing, email is sent to the consultant. So if the data has any kind of errors, always the email is sent to the consultant or the data provider until the data is valid. So if the data is valid, schema transformation is done, and lastly the data is written to Finavia's database. There were some challenges during the project, and one big challenge was the differences between the data models of the source XML data and Finavia's database. So the source XML data is very hierarchical. There are a lot of different XML elements which connect to each other, and the analysis results, they are in separate elements in the XML document, but Finavia's data model is very flat, as you could see in the previous slides, that there are just rows and columns. And here is the source XML data. So there are different elements here, and they contain the different analysis results, for example, pH, temperature, smell, etc. And this should be the destination data model. So for example, here, if you look up here, there's under analyysitulos, there's NO23N, which goes to the destination data model column, same name, NO23N, and the value comes under that. And same thing for every different analysis result. So this is the workspace that does the magic. And all the red parts, all the red bookmarks here in the workspace mean errors, error checking basically. And all the errors from different parts of the workspace are merged together at the end of the workspace, and the email is generated from that. So basically what's done here, on the left side there's the reference schema, and the data which comes from the data provider. And first, feature types are checked if there are any missing feature types. And that's done basically with feature merger. And then all the different attributes are checked. And this was quite a challenge, how to make sort of dynamic way to check all the different attributes and their values, because there are around 10 different feature types and they all contain different attributes and they all have to be a certain attribute type or from a code list. So I created a custom transformer which on the lower left side takes all the code lists in and then compares the code lists to the attributes and then writes an error if there's an error or lets the data out if there's no errors. So the nice thing with custom transformers, of course, is that you can always have many instances of the same custom transformer and just change the parameters of the custom transformer. So this custom transformer selects first which feature types to check, then which attributes to check, and last you can define the attribute types, for example, double or string. So it looks like this. First, there's the feature type that's in the second parameter, user parameter, and you can select the feature type and then the attributes and last the attribute types. And for the attributes, you can use the for the parameter you can use the tree view, which is now in and has been in FME since last year, I think. So it helps with XML data, the tree view, a lot. And when the data is valid, it is transformed to the flat schema. And it is done basically with list transformers. And first I'm building a list from the XML elements with list builder, and then I have to get the attribute and their values. But there's a problem that in this data I have the codes as values of a list and the attribute values also, and they are like separate. So I used list builder, list renamer, and record builder. Record builder was a new transformer for me. It's a custom transformer which can be found from FME Hub, and the record builder does actually all the magic, all the flattening magic. So what record builder does is on the right side. So you have to have a list which has the attribute names, and then another list which has the attribute values. And the elements are corresponding by the index of the list. And record builder builds or creates the attributes from the first list at names and then gives the values for the attributes. So that does the flattening thing. And when the data is not valid, then there's an email sent back to the consultant, and I'm using emailer for that one. And it can look like this. Like, hello, the water monitoring dataset contains following errors, and then there's the feature types listed, and the attributes are listed. So as long as the data is not valid, the consultant or the data provider gets always the email back, and the data is not written to the database. And when the data is valid, it is transformed and written to ArcSDE, which is their database. So, good thing about this automatic process, this is actually on FME server, works on FME server, and we are using the monitoring service, which you can have like a folder there, and FME server checks if there are new files, and then automatically runs the process. So FME saves time, and of course the most important thing for many people is that it saves money. And actually, one benefit, a big benefit of this project was, which we saw at the end of the project, that they had a tender going on in the one of the airports, and there were different companies which were in the tender, and Finavia was asking them to provide the data in the new XML standard. And they actually could test with this process that which company of the tender offers is the best one for them. So they actually used this process to select the best tender. And I think they will be using this same process for different airports also, to select the best tender from the competing offers. Well, the project is still continuing, and we will start monitoring the errors in the future, their types, their amounts, and of course which data provider produces most errors. And we will use like sort of graphs and different kind of graphics that the customer Finavia can see right away which data provider is doing a lot of bad stuff, and then they can say to them that, hey, you have this kind of errors all the time repeating, please fix your data. And of course for the tenders they can also use this process. So, thank you. Do you have any questions?
Any questions for Lassie? One of the things we've seen is that a lot of APIs like this using JSON instead of XML. Are you going to tell us which one you think is going to win out over a while, JSON or XML?
Well, I think none of them will win. There will always be people for JSON and people for XML. So yeah.
And the other thing is, you're talking about the errors there, and presenting those to Finavia. Is that going to be a BI tool, Power BI or something? You're going to build a nice dashboard with one of those things? Is that?
Yeah, perhaps. Yeah.
Any other thoughts for Lassie's come all this way from Lapland to present? Yeah, Dean.
Sure. I'm just curious if it seems like a really cool template to be able to do this kind of summarizing of the validation process and generating reports. Have you thought of applying this to other areas like Inspire or other Finnish data themes standards?
Yeah, we haven't thought about that yet, but yeah, of course this could be used for that too. But of course you have to change then the schema validation thing, but yeah, it can be used for other schemas also.
Okay, looks like everybody's keen for lunch. Yeah. Just a reminder, use your app to give Lassie some feedback on his presentation. And thanks very much.
Yeah, thank you.